Nice visible for you. We have the okay. So what we are discussing today, we are actually focus on the basics of the microfluidics, like definition, principle, example, and application, and we can say this conclusion is the challenges. We will discuss this today. If you have any doubts, you can ask in the whatever the professor section has said. Yeah. So if I won't be able to solve that, I'll convey to the professor. He will take care of that thing. And next week on Sundays from 3 to 5, we'll discuss further what the doubts, whatever you have, we will solve this. Okay. But introduce like micro nano fluidic device. So micro systems are miniaturized components devices. Sentence flow is manipulated in highly ordered channels. So this micro fluidic devices ranging between the 1 micron 100 diameter and device diameter of 100 nanometers. So it looks like this, where we can see that channels are there, and these channels are made up of large polymers, paper, and gel. Mostly it is made up of polymers. The use of an application in the polymers is very high compared to glass, which can break easily, and the gel, which is very, we can say it's not switchable material for the fluid device. If we have how the devices are fabricated and the input and output uh, channels are there. So what is used first of all they are liquid. So there are different kind of materials in there, like liquid kind of things, gases and other materials like mixture of the liquid and gases. Okay, which can continuously move and deform until the applied state there. Microfluidic devices, there will be different kind of samples we can use as a fluid, like food blood samples can use, and it can be uh, made solution towards the point here diagnosis, such as like some diagnosis if you want to do, you can use that samples, blood samples, and for the fluidic input side, and it will run the microfluidic device, and you get the data and through that we can do the data analysis. You can see the side how the images are found here. Okay, so the blood will flow in this where you have different kind of antibody production or something. Okay, and that can be like diagnosed as a electronic device. Same time we have by the bacterial cell processes, protein antibody solutions, and various purposes like uh, precise mixing and analysis of the chemical reactions to check the dynamics of the chemical reactions. So the principle of microscopic device are like various kind of principles are there, only not only one. So first I'll discuss the three parts. Basically, so radiating phenomena is essential node in the microfluidic device or nanofluidic device, where it works as on the electro-osmosis or electrophoresis. Okay. Everything is going on. Am I audible for you? Is it disturbing noise? Neha? Is it clear to you all right? What I'm saying? And, okay. Other people? Otherwise, I think there is some problem now. Just a second. I'll connect with the something else. Am I audible now? Please tell me. Audible. Okay, Neera. Somebody Wamsi, Cindy, is it clear?
Not Chandu.
Yeah. So we were discussing the principles of the microfluidics. In that we have discussed the electromagnetic phenomena, where we use the electroosmosis and electrophoresis um, phenomena for the microfluidic device. And the thing is like when electric field is applied across the nano channels, or you can say that nano channels having states, it induces the movement of ions and fluid molecules within the channels, creates an electroosmotic field. Okay, osmotic field. Then electrical double layer. This is another principle for the microfluidics, where the electrified interface are like organized charge distribution called electric double layer form near the surface, and this nanometer size force, and that the double layer may be span the entire width of the pore. Okay, and leading to a significant changes in the fluid composition and the properties. Actually, I'm not aware of this particular principle like phenomena of the microscope. But I'm just I have taken some from this. And the another unique properties like fluid confinement and viscosity, like increase the viscosity near the pore wall, which alter the thermodynamic properties and modify the chemical reactivity at fluid solid interfaces. So mostly I am aware about the solid and the chemical reaction in the homogeneous state of the microfluidic. So that that is my topic in research. So I am aware of this one, but I am not aware of this technical double layer principle. Here you can see this images A and B, where the buffer and the samples have been inlated this microfluidic device, and this through this channel, it will go it will go to the another outlet, another point outlet, where it is having the waste outlet and the PCC outlet. Like it's kind of uh, the mixture of the sample inlet and the buffer inlet. It will um, propagate to the another end. Okay. Here also same thing is showing, where the buffer channel and the sample channel mix together, and where the some sample molecules will go to the buffer channel, and it will react with that. Okay, the waste will come out to the another port. The other key principles are like laminar flow. So it should be having the laminar flow parallel layers without mixing significantly, and then diffusion, small molecule diffusion across the channel, and surface effects. The surface interactions impact fluid behavior. Then again, there is electroosmotic flow. Okay, so electric field drive fluid movement. When you do apply the electric field, it can be deviate the fluid movements. So for fabrication, here I'm showing the fabrication of the microfluidic devices. So for design and fabrication, it will be having different kind of like channels, chambers, and walls. Okay, or molding of the substrate using the polymers. This walls can be etched or molded. Okay, so etching can be done by the some method will be there, reactive ion testing there. Then apart from this, met focus then milling etching will be there, and electron beam laser etching will be there. The molding part will be like you have this like a nanometer or a micrometer mold. In that, you keep the substrate and you, like a polymer or a glass, this substrate, and based on that, you will get the microfluidic device. Okay. Whatever design you want, you have to prepare first in the AutoCAD or somewhere where it will be having the design can be like read by the machine. Then it can be molded on the physical form, molded in the physical form. And so this channels can be narrow some micrometer or nanometer also is possible. Nanometer for that very high precision instruments to get the nanometer level microfluidic device. And the fabrication fabrication the techniques can be used like for fabrication, photolithography, soft lithography, and microfilling can be used. Just now I told you the focus and reactive and etching and all. Okay, so maybe I'll discuss the design fabrication in the next part, next section properly. It is very detailed. It can be a very detailed uh, topic. So I'll just discuss this in the next class, okay? Next section. And you see this design and fabrication along with this fluid flow control, we can't do anything in microfluidic device. So there will be some kind of capillary forces, pressure gradients, and electromagnetic effects. We have to take care of these things. All these. This is one kind of microfluidic device. Okay, and we have to think about all these aspects. And numerical parts also we do in the next class, not now these two classes. Okay. We have to think about the internal and external pumps. Okay. Not internal actually, external pumps for inlet and outlet. Okay. And valves also have to be precisely controlled to get the proper flow in the microscopic unit. So there are so many applications such as lab on a stick. So you can see here the side image where this is a reservoir and it is going to the wall. This wall can be changed according to the which side we have to give the flow. Okay, either we have to switch off that or flow we have to shift to the other side. Then isolation, sorting, translating, differentiation monitoring, and migration testing. We have to this kind of thing can be done in this. Okay, lab on a chip. You can see here so many people are working and they are working on the different aspects. But this can be uh, done in the chip level also. That's why we are telling that lab on a chip. So it can be done in this small piece of the microfluidic device or nanofluidic device. So whatever the blood samples we are taking and we are using for the analysis nowadays in laboratory, we require very less amount of sample in microliter or nanometer to get the high accuracy results for the test. Okay, so biomedical technology, as just now I told you, and chemical synthesis. This is a very much important aspect of this nanofluidics device because the synthesis is happening in the chemical level or in RB and compared to the in a nanofluidic device or nanometer level, where the molecules are like we can say that separately it can be seated in the nanofluidic device, how it is reacting, so that can be analyzed easily with the nanofluidic device. Then for drug discovery also it can be very useful. Uh, like with drugs, it can be uh, uh, input the as you can say protein or some kind of molecular state. Okay, so which can be also useful and self-study can also be done in this. Other applications like detection and analysis, suppose optical chain detection, so fluorescence and absorption of the which are occurring in this particular storage device that can be detected. Integrated sensors monitor reaction and imaging techniques that captures the cell immediately. So there are like applications are so many applications are there, but with that challenges also will be there. There, I'm going some five challenges, which is complexity and customization. So whenever you want to go for the like high precision microfluidic device, then the complexity will be more in that particular aspect. And also customization is not that much easy. You have to think about the every aspect, which I have discussed in the principles. Okay, and fabrication and cost also it is not viable now. Maybe in future it will be very cheap. We can say now the fabrication with photolithography and soft lithography and the etching and this kind of instruments are like chances will be very high, or we can say if somebody buying that institute will be having charge like the price will be very high. And sample preparation also very complicated. If you are making this polymer-based microfluidic device, then the charges will be lesser. Sample preparation, but you don't have to control the fluidic channels. There will be so much roughness inside the fluidic channel, possibly, and yeah, this kind of things can be possible. Then material selection. So, if you are selecting the glass for microfluidic device, okay, so it is very difficult to handle that. If it is falling down, then it can break also. So that's why we are using the polymer. But polymer is not suitable for all the uh, applications, we can say. Suppose if you want to do some kind of reactions, chemical reactions, polymer is not at all good. So we have to think about this one also, the selection, which kind of material we use. And automation till now it is very difficult to know this microfluidic or microfluidic device because it is in a microfluidic or nanofluidic you can say because it is in a nanometer level and defects are like uh, errors getting errors the chances are very high compared to the other uh, ordinary material methods we can say. Okay, and equipment also very quite costly for this. So these are the challenges. So for today's things, like today's discussion, I think this is enough. If you have doubts, you can ask me one by one. You can ask me chat also. You can ask my question. Um, you can tell also. Okay, please. If you have a question. The other part, like applications in details, we discuss in the next session, and also device fabrication we have to discuss in the detail in the next session. Please ask guys if you have any doubts. If you have any doubts in the week one session or week one also, NPTEL course week one, there also you can ask some questions. And questions here. I can't solve because it is live now. Till 7 or 8, you have to submit the week one assignment. After that, we can discuss again. I can just give you okay. Dheeraj, Riyaz, Swamsi, please ask if you have any doubts in that. Or any suggestions if you have. What do you want to learn? More specifically, if you want to learn something, then you can give suggestions.
Hi, Ankur.
Yeah,
So, will this course actually also talk about modeling, mathematical modeling of the flows through these microchannels and nanochannels, or only the theory around how they are used? Um,
I didn't get you. Like in course you are talking about is modeling tools are there or not, like that.
am I audible now? Sorry.
Are you asking that in this course, in this NPTEL course, the modelings are there or not? Like that you are asking or something else?
So
Mathematical.
I'm asking if the mathematical modeling mathematical models of the fluid
Okay.
motion within these microchannels, is that discussed, or is it only about the practical applications of micro and nanofluidics?
Yeah, both are there. Both are. Professor has discussed both things. Okay. So whatever, if you have some doubts, you can ask me here, sir. I'll clear in the next session or maybe this session, like that and will go. Okay. If you have a broad topic where you are struggling so much, you can ask me in the chat. So next time I'll prepare that one and I'll discuss with you guys. Okay. Did you get my answer? Answer?
Yes, Anku, thank you.
Yeah. Yeah. Nobody's there? Any other questions? Please ask. It's for you only, guys. Whatever questions, whatever doubts you have, feel free to ask me. If I don't know, then I'll ask the professor also for you guys. So don't be hesitate for the asking the question. I think I'll wait for some questions. If it is there, then we'll go for. If it's not there, then we'll close the session. But I feel like if you have any topic related doubts, you can ask me. That can be very good for me and as well as for you also. So I can teach you, I can also learn something. Mathematical once we will do third or fourth week, I can say that. Mm, Not that modeling kind of thing, but yeah, the basic mathematical part of the microfluidics.
Okay, go. Yeah, understood.
Yeah. So Vamsi, you are working in which your master in which topic?
I'm sorry, was that a question for me,
Yeah,
Ankur?
yeah. As a asking you, like, where are you doing your masters?
I'm doing masters in ICME in IIT Hyderabad, from IIT Hyderabad,
Okay.
Integrated Computational Materials Engineering.
So it's like you were thinking that it can be useful like a modeling, mathematical modeling and fluid design.
Yes, so I would like to apply ICME techniques for microchannels and nanochannels
Okay.
also. So want to see if at all that is covered as part of this course.
I feel you can go through some papers, year papers from Professor Suman Chakraborty. He has done so many things. Maybe you can get some ideas from it.
Oh, okay, cool. Yeah. I myself had worked in my BTech on preparing the model for mathematical model for two-dimensional microchannel flow and
Okay.
simulating it
Yeah.
to study the compressibility effects. But that was in 2006.
Okay.
So I need to see what more progress has been done in the recent years. Yeah.
Okay. So anything if you want to discuss in the next class, one thing specific thing.
So how frequently are these sessions, Ankur?
This will be weekly. Sundays, 3 to 5 p.m. every week.
Every Sunday. Okay, okay, okay.
Yeah.
Okay, one maybe a generic question. I don't know if everyone has it or not, but so you don't have to answer if you are if it's too much. So the questions I see are MCQ, yes, but would there be some kind of an assessment kind of assignments also given where we would be expected to solve certain problems, or
Yes.
all the assignments would be MCQ only?
I think you should solve all the assignments, like weekly assignments. If you are
I'm
going
sorry,
on the weekly
your
classes,
voice is breaking, Ankur, again. Sorry, maybe it's only me or
I'm audible now.
your voice is again breaking. You're audible, but some at some
Sound,
places it's
sound.
actually breaking.
Okay. So, what I'm telling that weekly assignments will be there. Weekly, you have to discuss you have to go through the classes. Then after that, you have to do the assignments. This assignments marks also they professor will include the final test. Okay. With that, you will get the what we can say the final equivalent 75 and 20 from the assignment. weekly assignment. So based on that, you will get the certificate. Maybe I'm audible for you.
Yes. Okay. Yeah. 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 I get it. So now my question was more like, so weekly assessments are all going to be MCQ only, right? In that case, multiple
Yes,
choice
yes,
questions only.
yes. Multiple choice.
Okay. Okay.
Yeah. I think if you go from the professor's slides, then you will directly can answer. Then you can directly answer.
Yeah. Actually, yes. Yeah. If we go through the slides, I think yes. And most of them are theoretical questions. That's the reason I was asking this if there is any. Uh, but anyway, as you have said, maybe in the third and fourth week we would actually get into the more practical
Yes, yes.
aspects of how the fluid actually flows through the channels.
Yeah, yeah.
Sure, sure. Yeah.
If you wish, you can leave also. Maybe I think nobody's having doubts. So maybe I will close the session.
If it's not too much to ask, can I know what's your research interest? Mhm.
Actually, I'm material chemistry based. My background is material chemistry, and I'm working in the photonic circuits, like organic photonic circuits, where I'll implement
Yeah.
like organic crystals. Like organic crystals, generally crystals will be brittle, but here organic crystals are very flexible. So that's the advantage we are using for the application of integrated circuits.
Okay, nice.
Yeah,
So
it's a
I
yeah, yeah, please.
go ahead, please.
Yeah, it's like related to my photonic part and like we can say uh, nanofluidics also can be covered in this part aspect because nowadays this optofluidics also immerse so much. You're asking something?
I'm not sure if I'm audible. That's why I have put the question in the chat. I actually registered for this course which said microfluidics and nanofluidics,
Yeah.
but in your first slide,
Oh yeah, yeah.
your very first slide,
Actually,
it's a
yeah.
introduction to photonics.
Yeah, I'll change it. I'll change it. Sorry for that.
Are they both the same, or are
No, no,
we?
no, no. It's not same actually. I'm sorry for that.
Yeah, that's what. So no, no, that's okay. Thank you.
Last
But
time,
we are discussing about microfluidics and
yeah,
nanofluidics
yeah,
only, right? You are again inaudible, Ankur. So
yeah. I told that. Like, am I audible now? Can you hear me?
yes, I'm able to hear you now.
Yeah, actually, there was one mistake actually. I took last time this photonics classes also, so that's why maybe I forgot to change that. I'll change that. Mhm. Thank you for reminding me.
No issues, no issues. Thank you very much for clarifying. Any particular prerequisite that you think we should read before before attempting the questions? Ankur?
I
Other
think
than what is given, of course, like like what I mean is, I know transport phenomena is important, but is there anything else that should be read through before attempting to take this course
I
to
think
to be able to solve the assignments effectively?
uh, I think the outside like stuff you don't need it. Professor has been covered all the aspects, whatever he is asking. You can just go through his slides. Most things, most of the things I can say that 99% are in the slides only. His weekly
Oh,
classes.
okay. Okay. Cool. Okay.
I think
I don't think I have any other doubts. I think I've asked enough already.
yeah, thank you for
Thank you.
reminding me this
Ankur.
title was wrong. Maybe somebody could have got catch that.
Yeah. I was thinking that Professor Suman Chakraborty is so I did not ask this at the start.
Okay.
Right. I can drop off, right? So I think I have had my questions answered, but maybe because it's a weekly session next week, maybe we can again connect and then see what else can
Yeah.
be discussed.
Sunday you can join. See you.
Oh, Sunday 3 to 5, is it? Okay, cool. Yeah. Thank you very much, Ankur. Thank you.
Okay, welcome.